Oh my god, I hope this thing is recording. Okay guys, so today we have started with regression, and basically I told you the difference between correlation, regression and causality. And I also told you that today we'll be focusing on regression, and we have two types of regression generally. We have simple regression and multiple regression analysis. With simple regression analysis, we have just one independent variable, or you can say one regressor. So therefore, we have just two variables, that is one dependent and one independent. Just two variables, just one independent variable. But with multiple regression, we have more than
Sorry, but
more than two independent variables. Therefore, we have at least three variables in total. So with multiple regression, we have more than one, not more than two, more than one independent variable. So we have, that is two or more independent variables, but with simple regression, we have just one independent variable. And today, we are going to focus on simple regression. So we are going to look at just one independent variable. Let me open, by the way, let me share my screen. I almost forgot. Share screen. I hope this thing is recording. Okay. Share screen. Okay, I believe my screen has been shared. Now, what do I want to do now? Okay, let me open Microsoft Word so I can write something. So like the regression model, like regression, we have two types of regression analysis generally. Regression, and we have multiple. So with simple regression, have something like this, y beta 0 plus beta 1 term. While with multiple regression, econometric model can be y beta z. So what do you notice? By the way, whether simple regression or multiple regression, we always have one dependent variable, y. Now, with simple regression, we have just one independent variable, x. These beta 0, beta 1 are not variables. They are parameters. Beta 0 is a constant term or the intercept. Either you call it constant or intercept. U is the error term. Beta 1 is the coefficient of this x variable. So we have just one variable here, which is x. So we have just one independent variable for simple regression. For multiple regression, you see here this independent variable x and this is independent variable z. So you see that we have more than one independent variable, that is more than one regressor. So we have two here. It must not be two, it can be 3, 4, 5, but just know that more than one. Okay. So you notice that with simple regression, we have just two variables. It is one dependent and one. With multiple regression, we have more variables. That is one dependent and more. So these simple regression models are basically at times called univariate models. Why these multiple regression models, at times we call them so univariate. Why? Because there is just one independent variable. Multivariate because there are more than one independent variable. That's fine, right? Okay. So today, I'm going to remove this multiple regression because I'm going to focus only on simple regression today. Simple regression. Now, this is, how do we call this? We call it our model, or you can call it econometric. That's the model. Now, we want to estimate these parameters. We know what y is. Y is a variable, which is the data we download from World Bank, Yahoo Finance, any database. X is the variable, that is the data we download. So we know y and we know x. Error term is there. I told you what error term means. It accounts for all those other factors which can affect y, but which we don't want to include in the model. So we know y, we know x. But we don't know beta 0 and we don't know beta 1. We don't know these two things. Now, we need to estimate these two things. So we need two figures. On e-views, we want to get the figure for beta 0 and the figure for beta 1. So those are the two things we'll get from the e-views. If we get these two figures from e-views, then we can write our estimated model. Let's assume that beta 0 equal 5 and beta 1 equal 2, just like I showed you in class. So if we assume that beta 0 is 5, which obviously is the intercept, the constant. This beta 0 here is our intercept, or the constant term. And what is beta 1? Beta 1 is the coefficient of x. That is, this beta 1 is the coefficient of this x value, this x variable. So let's assume our beta 0 is 5 and our beta 1 is 2. We are going to estimate it on e-views and get the figures, but let's assume first that these are the figures. If we have these figures, then we can write our estimated equation. Our estimated equation will be, this same equation, a copy. Our estimated equation will be that, but now instead of beta 0, we'll put 5. So I'll come remove this beta 0 and put 5. And instead of beta 1, we'll put 2. So I'll remove this beta 1 and put 2. And then I will delete this error term. Again, I told you in class, I'm repeating here. For the model, you include the error term. But once you estimate the equation and you get the parameters, you get the coefficients and the constant, the parameters, and you are writing the estimated equation, you don't include the error term again. You have to be careful about that. So this is our estimated equation. Now, after we have gotten the estimated equation, the next thing is to interpret it, because you need to get the estimated equation and then interpret it. Because what are we doing in regression analysis? We are trying to look for the relationship between variables, between the dependent variable and the independent variable. We are trying to find out how the independent variable affects the dependent variable. So if we get this equation, our dependent variable is y and our independent variable is x. So the coefficient of this independent variable is 2 So you see that this 2 tells you how X affects Y. So you have to interpret it. But then while doing this interpretation, you have to be careful. You have to check, you have to know if you are dealing with level regression. Is it a log regression? Is it a level log regression? Or is it a log level regression? Guys, 1 minute please. Let me take this call. Okay, so if it is a level regression, then like I told you in class and I demonstrated on the board, when you're interpreting it, you use the units of all variables. It's a log regression, that is, you use log all true, that is all the variables have log. Then you interpret it by putting everything in percentage, right? Then if it is a level log regression, or if it's a log level regression, we have to be careful. I demonstrated in class. For instance, by the way, let me copy this regression model. For level regression, we can have something like this. What have I done? For level regression, we can have something like this. You see, Y is level, that is original data, X is original data. For log regression, we can have like this, let's put everything in log. So this Y will be in log, that is in, and this X will be lin. So you see we have taken the log of Y and we have taken the log of X. So that is log. For level log, it will be like this, Y level, but X will put, and for log level, Y will be log and X will be level. So you discover that in this our case, we guessed, we assumed that our intercept is 5 and the coefficient of X is 2. Y here is level and X here is level. So in this our mini case we did here, this is level. And while interpreting it, you use the units of all the variables. If it is log, it is the easiest way to interpret. You use everything in percentage. Okay, now level log, how do we interpret level log? With level log, you have to be careful because like this, oh my god, 1 minute please, let me take this call. Hello? Okay, yes, I'll send. Okay. Okay. Yes. Yeah, I have in my receipt folder and I'll need to open it and I'll send. Okay. Sorry, guys. I had a call, urgent call. I had to take it. Okay, now, so with level lock and lock level, let me start with level lock level. You discover that here our y is lock, but our x is not in lock. So that's lock level, right? How do you interpret it? You will say like if x increases by 1 unit, you put the units since it is level, so you use the units, you will not use percentage. Then y will increase by this number here, this coefficient, by beta 1, but we have to multiply it by 100. By beta 1 times 100 and ln, so it's percentage. Beta 1 times 100%. So you have to be careful there. You multiply by 100. For level log, you say if like level log, y is level, x is log. So what you say is that if x increases by 1, here is log, so we'll use percentage, not unit, by 1%, y will increase by this figure here, beta 1, but you have to divide by 100, beta 1, and since it's level here, you use a unit, not percent. And remember, in all cases, you must always mention on average. Average. Very important. Average. And you see here, I said if x increases, y will also increase. Yeah, if x increases, y will also increase. Y must not increase all the time. Y can also decrease. So it depends on this value here. If I change this plus to minus, then I will change this increase to this. So you have to always look at the sign of the coefficient, because not just the coefficient which will tell you what will happen to y, but the sign will tell you if that thing that is happening to y will be increase or decrease. Is it an increase or a decrease? You have to be careful. So that is fine, right? Okay. Now, I said all of this in class. I'm just repeating so that those who do not understand in class, if they watch the video, maybe it will help them. So now let's go to E-views and see how we can estimate these coefficients, write our estimated equation, and then interpret. Okay, so I'll open a new file. So now in my Microsoft Excel, I have here, where is the Excel? Excel, I have two variables. This time series, right? Because we have 1990 right down to 2019, so it's time series data. We have just two variables, GDP and carbon dioxide, because we are doing simple regression. So we want to have just two variables, one dependent and one independent. So let's assume that this is our econometric model. Assume our model is GDP 0 plus beta 1 carbon dioxide not 10. That is our model. GDP is our dependent variable. Carbon dioxide is our independent variable. So we want to see how carbon dioxide affects GDP, right? Of course, beta 0 is our constant term or the intercept. Beta 1 is the coefficient of this carbon dioxide variable, and U is the error term. Of course, there are many other factors which can affect GDP, but we don't want to include them in the model. So this U accounts for those other factors which can affect GDP, but which are not in the model. That's fine. By the way, for those who are taking thesis, or you take thesis next semester, whatever, this can give you an idea of the kind of things you can do for your thesis. For instance, if you are using this kind of model for your thesis topic can be something like the impact of carbon dioxide economic growth. You know, this model is trying to show you the impact of carbon dioxide on GDP, but you know that GDP is a proxy for economic growth. So you can use this kind of model to do this kind of thesis. However, in your thesis, you will not use simple regression because they always use multiple regression. That is more than one independent variable. And there are reasons for that. I'm not getting to that now. I'm just telling you that you can have an idea of the kind of things you want to do in your thesis. Okay, that was an aside anyway. Fine, we have our simple econometric model. Now, we are trying to investigate how carbon dioxide, which is an independent variable, how does it affect GDP? Okay, so this is our variable, our data. We have the GDP variable and the carbon dioxide variable. We are going to do the estimation on eViews. So first, I'll open eViews. That's eViews opening. Create new work file. I need to check the dates. I'm checking from 1990 till 2019. So I go back to eViews. Start date is 1990. End date is, if you check, it is annual data. That is every year. So it is annual data. And since it is time series, we are using dated regular frequency. Okay. Now I need to input the command for the data. Data GDP CO2. We have just two variables, right? Let me check. Yes. Just two variables. Of course, it's simple regression, so we should have just two variables. GDP CO2. That's fine. So once you do that, just press enter. You have the work file, which opens. Now all you need to do is you just copy your data. Copy only the data. Don't copy the title or the years, just the data. What I always do, I just click on the first cell. I scroll down. I want to click on this last cell, but I first of all hold Shift and click. I select everything, then copy. You can either copy by Control C, or you can right click and choose copy. It doesn't matter. Once you copy, you come here and paste. Paste in the first cell. You can paste Control V, or you can right click and then paste. It doesn't matter how you do it. So I have pasted the data on eViews. I can now delete untitled group. Yes. If you delete it, don't think that you have deleted your data or no. The data is there, like this is the carbon dioxide series, this is the GDP series, that is it. So we have exported the data from Excel to eViews. Now, let's go back and look at the model. You see the model is level. GDP is level. Carbon dioxide is level because we are not doing logs. Had it been, it was here like lean GDP, then we'll do log for GDP. But it is just GDP. So we don't need the logs. We need just the data itself. Raw data, level data. So no need to generate the log. Now, we want to estimate the parameters of the regression. Come here to, by the way, there are many ways to estimate it, but I want to show you the easiest way to make your life easy. Come to quick, click on quick, come to estimate equation, click, and then here now you have to write something. What do you write here? What you write here depends on your model. Come back to the model. Where is Microsoft Word? Look at your model. Your model is dependent variable GDP. After dependent variable, you have constant. After constant, you have independent variable carbon dioxide. So that is how we do it. You go to eViews. What you write here is GDP. You always start with the dependent variable. Be careful. You give a space. You write C. That C stands for constant. You give a space. Sorry, C. You give a space. Then you write CO2. Again, look at the model. The model is GDP, constant, carbon dioxide. So you first of all write the dependent variable, you write the constant, and then you write the independent variable. On eViews, that's what I've done. You write dependent variable GDP, you give a space, you write C. C stands for constant. When you write C, eViews understands that it is constant. You give a space and you put carbon dioxide. You don't put any equal sign or any plus sign. You just write those three variables like that. That's all. Now, eViews is doing this estimation using a technique called ordinary least squares. Let me write it somewhere so you can see. Using a technique called ordinary least squares, that is abbreviated OLS. There are other techniques eViews can use, like maximum likelihood, but this is a technique that eViews uses by default, and this is the technique that we are going to use throughout this course for regression. So here they say method least squares, don't change it, just allow it. By default, you will always see least squares. But if you want to look, you discover that you have many other methods. Like you can choose a different method here, but we are using least squares. So leave it the way it is, don't change it. And here you see it shows you the data starts from 1990 and ends in 2019. Don't change it. So the only thing, so you are not changing anything down here. The only thing you are writing here is, first of all, write your dependent variable. After you give a space, you write C for your constant. After you give a space and you write your independent variable. That's the only thing you write. And then you come and click OK. Once you click OK, you get your regression results. This is your regression results. Now, like if you see, for instance, dependent variable is GDP, of course. Method is least squares, ordinary least squares, of course. Sample starts from 1990 to 2019. We have 30 observations. Sample size is 30. We are not interested in all this information. Now, the only thing we are interested in for today is the coefficients. These coefficients. Forget about this standard error, forget about this t statistic, forget about this prop value, and then all these things down here, arrow squared, adjusted arrow squared. We are going to talk about them subsequently. But for today, we are only focusing on these coefficients. We want to interpret these coefficients. That's the only thing we are interested in today. So how do we interpret these coefficients? Now, our coefficient, so this 3.96 is a coefficient of C, which means it is a constant. C is a constant. And this negative 5.8 is the coefficient of carbon dioxide, right? So once we have our coefficients, we can now write our estimated equation. I'm going back now, so I'll delete this. So estimated equation. So we have the model. I'll copy and paste. Now I'm going back to eViews. You see the constant, this constant, the coefficient is 3.96. So here I'll put 3.96. Actually, it is 3.96 times 10 to the times 10 raised to the power, like 10 raised to the power 10, but let's not get into that. Let's just assume that it is 3.96. Let's assume that we never had this E, this times 10 raised to the power 10. Let's just say it is 3.96. Not too complicated. For carbon dioxide, the coefficient is minus 5.87. Let's assume. Actually, it is minus 5.87. This E plus 10 simply means times 10 raised to the power 10. But let's not complicate it. Let's assume that it is just minus 5.87. That's the coefficient of carbon dioxide. So, yeah, coefficient of carbon dioxide is beta 1. So instead of this beta 1, I'll put minus 5.87. Was it minus 5.87? Minus 5.87. So I'll put 5.87. Then this, my sign here, will change to minus. So you discover that we have had our estimated equation and we have to delete this error term. So once you write your estimated equation, you no longer include the error term. So this is our estimated equation. Now we can interpret this. Since we have these coefficients, we can now explain how carbon dioxide affects GDP. So how do we interpret it? By the way, it is level because there is no log here, and carbon dioxide has no log. So what we'll write is that carbon dioxide CO2 increases. By the way, since it is level, we are using the units to interpret it. Carbon dioxide unit is kilogram, GDP unit is US dollars. So we are using the units. So we'll say if carbon dioxide increases by 1 kilogram, will decrease because here is negative. If it was positive, it would have been increased. GDP would decrease by this figure, 5.87. 5.87. GDP is US dollars on average. Never forget on average. Right? So that is how we interpret it. Had it been here was positive, let's say this coefficient we got here, this coefficient, if it was not negative, let's say it was positive, then here instead of negative it would have been positive, then here this decrease would have been increase. So you have to be careful, always look at the sign here. But since it is negative, so we are going to write this. That's fine, right? So that is how we interpret the data, level. Okay, let's do log. So let's do log. lock. So this model was level regression. So let's do lock. So means here I'll put lock E and lock. So I'll go to eViews. I'm deleting this. So in eViews, I have my GDP and my carbon dioxide. I want to generate the log. So I told you how to generate log. I'll type generate in GDP equal log GDP. I'll generate that of carbon dioxide, generate lean CO2. I've generated the logs. Now I want to estimate log equation, which means I'm using logs. So again, I come to quick estimate equation, and I want to write my variables here. Again, look at the equation. It is lean GDP, constant, and lean carbon dioxide. So you always have to start with your dependent variable. So I'll write lean GDP, I give a space, constant, space, lean carbon dioxide. That's all. And then don't change anything else, just press OK, and you have your results. So this is our results. So you see, this is our constant, that's C, and this is the coefficient of this lean CO2 variable. So if I'm to write estimated equation, estimated equation, this is how I write it. Actually, it is the model, and then we just fit in the parameters. By the way, I should delete first error term, because we should not put error term in estimated equation. I'm going out to eViews. I'm checking the constant term, it's 22.6. So I come here, I put 22.6. The coefficient of this lean carbon dioxide is minus 0.9. So I come here, I put 0.9, 0.9 as lean, and then it is minus, so I change this plus to minus. So that's our estimated equation. We don't include error term, and we have to interpret it. So how do you interpret it? Since it is log, we use percentages for everything. Remember here we were using the units, kilogram for carbon dioxide and US dollars for GDP. But since here it is log, we use percentages throughout. So what we'll say is that if carbon dioxide increases by 1%, it is percent throughout, then GDP will decrease. Decrease because here is negative. You have to be careful. If it was positive, we would have said increase. GDP would decrease by 0.9% on average. Never forget to write on average. Right? So to interpret it, you use percentages for log. Let's do log level. That is, we have this equation. So here is log, and then here we remove log, so it should be level. Okay, let's estimate it. So now I'm deleting this, delete. I go to quick. So I already have my log data here and my level data here, so I don't need to generate anything again. I just go to quick. I just come to quick, estimate equation. So it is log level. So I want lean GDP. Is GDP a dependent variable? Yes. Lean GDP constant. The carbon dioxide, I will not take lean, I'll just take normal carbon dioxide because it is log level. Estimate, and I have my results. So you see here coefficient is 24, that is constant, and then the coefficient of carbon dioxide is minus 2.88. So if I'm to write estimated equation, will be this same equation, copy. So constant is 24.6. So this constant should be 24.6. And the coefficient of carbon dioxide here is minus 2.88. Why is everything minus? Anyway, it's fine. Minus 2.88. So yes, 2.88. Here is minus. We have to delete this error term. Once you write estimated equation, once you have the parameters, you don't include error term. Be careful. So let's interpret this. Okay, if I showed you how to interpret log level, how do you interpret it? If x increases by 1 unit, so this is log level. So you discover that this x is level, it has no log, so we have to use units. This y is log, so we'll use percentage. But before using percentage, we'll have to multiply this coefficient by 100. I've explained all of this, so you have to be careful. So how do we interpret it? We'll say if carbon dioxide increases by, since this carbon dioxide is level, there's no log, we're using units. So we'll say 1 kilogram, not percentage, units. 1 kilogram, GDP will decrease. Again, decrease because here is minus. If here was plus, we'll say increase. So decrease by, here is lean, so we have to use percentage. But since it is log level, we'll multiply this coefficient by 100 before using the percentage. So you know 2.88 times 100 is like 288. So you say 288 percentage on average. Never forget to include on average. That's log level. Now, final one, level log. We have the model level, so I'll remove this lean so that it should be level, and I'll put lean here so that it should be log, level log. I'm going to views. I'm deleting this. I come to quick, estimate equation, level log. So our GDP should be level, constant, and our carbon dioxide should be log because it's level log. So then CO2, and I just come here and I press enter. Okay, we have the results. So you see constant is minus 7.9 and coefficient of lean CO2 is minus 8.5. So if I'm to write estimated equation, this same equation, copy. Now I'm including the parameters. So what was the constant? Let me check. Constant is minus 7.91. The negative constant here, minus 7.91. And what's the coefficient of that lane CO2? The coefficient of that lane CO2 is minus 1.85. So here has to be 1.85 minus. Again, delete error term. We don't include error term once we have estimated the parameters. How are we interpreting this? This is level log. Again, how did I show you how to interpret level log? This is level log. So since x here has log, it means we'll use percentage for x. Since y has no log, it means we'll use units, but we'll divide the coefficient by 100. You have to be careful. So I'll say that if carbon dioxide increases by, you see carbon dioxide has percentage lane, so we'll use percent, 1%. GDP will decrease, again decrease because here is negative. If it was positive, we'll say increase. So GDP will decrease by, we have to use the units of GDP here because there's no log, so we can use percentage. So we'll say it will decrease by a certain number of US dollars. But how do we get that figure? We have to divide this 1.85 divided by 100. By the way, 1.85 divided by 100 is, I think it should be, I don't have a calculator here, but it should be 0.0185. Is it? 1.85 divided by 100. Let me just calculate with my phone. That's my phone not coming on. Divided by 100 is 0.0185. That's correct. So you have to divide this coefficient by 100 before including it, before using it. That's fine, right? Okay. 1 minute. Let me reply this message. Okay, guys, so that's how we interpret coefficients after we have estimated our equation. Okay. If I go back to e-views, you will notice that we have the coefficient and we have the constant term. But why are we interpreting only the coefficient? Why are we not interpreting the constant? Of course, we are going to interpret the constant as well. We have to interpret the constant as well. So here the constant is 3.96. How do you interpret it? Basically, this constant is telling you that actually in this model, what are we checking? We are checking how carbon dioxide affects GDP. And we know that this is how carbon dioxide affects GDP using this coefficient. This constant is telling you that if you eliminate the effect of carbon dioxide, then this is what your GDP will be. So this constant is telling you that without the effect of carbon dioxide, the average, always use average, don't forget, the average GDP will be 3.96, and since it is level, we'll use units. US dollars. So that is how we interpret the constant, and please don't forget to use average. So how do we interpret the constant in this case? Here you see the constant. Okay. Since here is log, so we'll use percentage. So this one is like telling you that without the effect of carbon dioxide, the average GDP will be the average GDP will be 22.6%. That's how we interpret the constant. And we are using percentage because it is log. Here is level, so we are using the unit of GDP, right? Here log level, here the GDP is in log, so we'll use percentage. So this one is telling you to interpret this constant. What you say here is that without the effect of carbon dioxide, the average, again please never forget to use average. The average GDP will be 24.6. Again, here is log, so I'm using percentage. And finally, to interpret the constant here, this constant, we have a negative constant here. So again, without the effect of carbon dioxide, the average, never forget to use average please, GDP will be, GDP here is level, there's no log, so we'll use the units. So it will be negative 7.1, negative 7.91 US dollars. So guys, that's how we interpret the coefficients, and that's how we interpret the constants. The constant is also called the intercept. So you need to know how to interpret both of them, because in the exam, assignment, whatever, they will ask you to estimate the model using A-views and interpret the coefficients. So you need to interpret the coefficients. And when interpreting the coefficients, you need to be careful. Is it log? Is it log level? Is it level log? Is it level? Depending on the kind of regression, you need to know how to interpret it. And I've shown you all 4 kinds: log, level, blah, blah, blah. And I've shown you how to interpret all of them. So you have to be careful. So if I go back to regression, so just for today, I've showed you just how to interpret the coefficients and the constants. Subsequently, we'll be using all of these things: standard error, t-statistic, probability value. I don't want to confuse you for today. Since you have not done it with Nigaoja, we'll do it subsequently, but just know that we'll have to interpret all these regression results. Standard error, will not interpret it too much, but things like t-statistic, probability value, we'll be interpreting it. And then down here, we'll interpret things like the R squared, adjusted R squared, standard error of regression, F statistic, and then Akaike criterion, Schwartz, Hanna-Quinn, Debye-Watson. We have to interpret all these things. But for today, I've only focused on how to interpret the coefficients and the constant term. So don't feel that that's all. We have to interpret all these results. Okay, I'm deleting it. By the way, what did I know? I hope I've showed you everything. So I've showed you how to do the estimation of E-views and how to interpret the coefficients. Is there anything left? Let me see. Okay, that's fine. Okay, one of your classmates was talking about graphs, that I should interpret graphs. Let me look at your assignments. You send me your assignments. I don't. Let me look at the graphs. I'm sure all of you had the same graphs, right? So let me open one person's assignments and look at your graphs. Oh my God, too many files open. About 5 or 4 assignments. Which assignment can I open here? Let me just open any one. This one is PDF. Let me open this one. Who is this? Oh my God. Okay, let me check graphs. The person's graph. Okay, this is graph. So like how to explain this graph. By the way, the first thing you need to do is you need to know which is the dependent variable and which is the independent variable. So this one is from model 1. So let me go and check model 1. That's model 1. The person is not even write the model. Oh my God. So I'll go back now and check the assignment. Where is 1504 tutorials? Where's the assignment? Somebody replied me that the person cannot see my screen. I hope this thing is recording and my screen is visible, else I just hope I'm not wasting my time here. Oh my God. So I cannot see your screen. Anyway, let me open the assignment. I just hope this thing is recording and my screen is showing. So this is the assignment. Oh my God, I'm so tired. Okay, this is the assignment. So for model 1, you see our dependent variable is carbon dioxide. In fact, for all models, dependent variable is carbon dioxide. So we want to know how all these variables, I think this is renewable energy consumption, this is foreign direct investment, this is gross domestic product, this is total natural resources, rents. So we want to see how each of these independent variables affect the dependent variable. So if you are interpreting graphs, first thing you need to know what is your dependent variable. Okay, that's our dependent variable. Now I'm going to the graphs. Where is that PDF? I think here. Okay. So you see this is carbon dioxide. This is, these things are blurred. This is REC. This is FDI. This is GDP. This is total natural resources. So our dependent variable is carbon dioxide. Look at what is happening to carbon dioxide. Of course, you see here it goes up after it comes down and so on. We are not interested in that. We are not explaining what is happening at each stage. We are just giving you we are just looking at the average behavior of the graph. So if you look at this carbon dioxide graph, yes, it goes up, comes down, but on average, it is coming down because you see it is coming down here for a longer time than going up. So on average, that's why I say you have to always use the word average. So on average, this carbon dioxide graph is going down. We are interested in the average behavior. Look at this ROEC, I'll come back to it, but look at this one. This one is clear. You see this one is going up. So on average, this one is going up. This one, GDP. Then if you look at this one, you see this one, yes, this one, it fluctuates like going up, come down, going up, come down. But if you look at it on average, you discover an upward trend. It's like starting from down here, and even though it's fluctuating, but it's like going up. Even though we can see it has more or less a constant mean. Even though because it's like fluctuating around the same level, so the mean is more or less constant. If let me not complicate it, but on average we can see it's going up. With this one, there are fluctuations. We cannot really see if it is going up or going down because it's not like fluctuating and going up or fluctuating and coming down. It's just fluctuating and staying at the same level. So we can say on average, this one has a constant mean. Then with this one, you see, you can say from this period to this period, that is from this period to this middle period, it's like constant on average. Thereafter, it starts going down, right? So, first of all, you interpret what is happening to each of the graphs individually, and then after you tell me what is happening, how the independent is affecting the dependent. So first of all, look at the individual. So you come here, you say for the carbon dioxide graph, on average, is going down. For this one, you can say right up till, is this 2006? You can say right up to 2006, it looks like constant, like the mean is constant on average because it's like a straight line here. And then thereafter, after 2006, on average, the graph is going down. For this one, you can see from year 2000 till like year maybe 2008 is going up. Then thereafter, maybe there are some fluctuations. There is a sharp increase here around 2003 something, and then like here between 2000 and 2000 is like straight, is like constant mean on average, always use on average. With this one, you see there's upward trend, so you can say on average it is increasing, upward trend. Then with this one, you see that you can say there are lots of fluctuations, so it's difficult to see the average behavior, but there are lots of fluctuations. So you interpret it like that individually for all of the graphs, and then now you need to also say how each of them is affecting dependent variable. So of course our dependent variable is carbon dioxide, and it is going down on average. This one, GDP, is going up on average. So you discover that carbon dioxide and GDP have, one is going up, the other one is going down. So it's negative relationship, because if it's positive relationship, then both of them are going in the same direction. If one is going up, the other one is going up. If one is going down, the other one is going down. The same direction for positive relationship. But if they are going different directions, it is negative relationship. So since we have identified negative relationship between GDP and carbon dioxide, what we'll say is that based on these graphs, we expect a negative relationship between GDP and carbon dioxide on average, or we expect GDP to have a negative effect on carbon dioxide on average. Always use the word on average, right? So that's how you can explain it. Then these ones that really have lots of fluctuations and we cannot really see the average behavior, it is difficult for us to explain how it will affect carbon dioxide, because we cannot really see the average behavior here because of lots of fluctuations. So for these ones, you can just explain it individually without telling me how it affects the dependent variable, no problem. I don't know, I just hope that is fine and you understood everything. Okay, I think that is that. So now I'm going to stop the records. Recording, yes, it is recording, and I'm seeing here stop sharing, which means it is sharing. So I'm sure my screen is visible and it is recording. So I'm going to stop recording. By the way, if you watch the video and you don't understand anything, you can ask me anytime. Send me a message on Teams, come to the office anytime. Ask me in class. If there's anything I do not explain well, I can explain again. Why is this thing not? Okay, let me stop sharing content first. What's happening? Let me just leave the meeting. Okay, guys, see you. Bye bye. Next class. It's like my screen has frozen now. What's happening? Okay.